What's good, people? Welcome back to the second video of the series of Solana Cookbook. So today we're going to be talking about programs. So in the first video we talked about accounts, and we're going to talk about programs. So looking at the cookbook here, any developer can write and deploy programs to the Solana blockchain. Programs known as smart contracts on other protocols like Ethereum serve as the foundation for on-chain activity, and they power everything that we see in the entire space, from DeFi to NFTs to social media to gaming to metaverse to all of the other different things that we see going on right now. So anyway, these are the foundational concepts behind how one account is interacting with the other account on the blockchain. So taking a quick look at the fact sheet here, programs process instructions from both end users and other programs. So interesting thing is you're making transactions with one person, for example, one other person, but then you could also be doing it with a protocol. So if you are on a marketplace, for example, like Magic Eden, you are listing your NFT to sell it, that's a smart contract that's being executed on that end, right? So you're giving your NFT to the marketplace and it's being locked in a smart contract because you listed a price that you want to execute that smart contract at. Someone else on the other end of the marketplace can see that contract, and they could either agree to purchase your NFT, or they could just leave it. So that's kind of an idea of what the smart contract could look like in the NFT world, for example. And you can kind of take that and use it in any other way, which is kind of the interesting thing. It's just an architectural piece. It's just a piece of technology, and you can basically use it however, for lending, you can use it for borrowing, you could use it for a multitude of things that I even possibly can't even think of, but you may have those ideas in your head. So this is why we're learning about the tools and the pieces that exist so we can use it to build for each other. All programs are stateless. Any data they interact with is stored in separate accounts that are passed in via instructions. So a program doesn't have a state. The data that they interact is stored in a separate account, just like we talked about in the previous video. So that program account and then the data accounts, they are both separated, but then in your application, you pass the data accounts, the data inside the data account in to, through instructions to the program account, so you can execute some type of, wonderful things with both data and the power of executables. Programs themselves are stored in accounts marked as executable. So they are labeled on the network as executable, and they are an account. So again, accounts are the key piece of Solana blockchain. All programs are owned by the Bpf Loader and executed by the Solana runtime. So I don't think this is a grand thing that everyone really needs to know too much details about, at least right now. Just know that this is the case. It's owned by Bpf and executed by Solana runtime. You can take a look at that on your own time if you want to. Make sure you do give it a quick look and see what it's about. Developers most commonly write programs in Rust or C++, but can choose any language that targets the LLVM Bpf backend. So Rust is a key piece of programming on Solana. Rust, but you could also use C++ if you're familiar with that. I've heard a lot more people lean towards Rust. That's just what I've heard, but I think it's a matter of preference. So if you can go ahead and use C++, make sure you do. All programs have a single entry point where instruction processing takes place. Process instruction parameters always include program ID, which is the public key of that account, accounts, which is an array, and instruction data, which is the information trying to be passed in some way. Again, this goes back to the data they interact with is stored in a separate account passed in via instruction. So instruction data is being passed into the program accounts. So unlike most other blockchains, Solana completely separates code from data. Again, you can kind of see it as the program and the data. All data that programs interact with are stored in separate accounts and passed in reference via instructions. This model allows for a single generic program to operate across various accounts without requiring additional deployments. Common examples of this pattern are seen across the native and SPL programs. So we have two different types of programs. We have the native programs and we have the Solana program library. Solana comes equipped with a number of things, and these are, for example, the native program, again, are the base functionality that's required to operate validators, for example. So validator nodes are the ones that are validating transactions and placing them on the blockchain. Among these programs are system program, which is basically making new accounts on Solana or transferring Solana between two different parties. The SPL program supports on-chain activities like creating, swapping, or lending tokens. So for example, you can create your own tokens on the Solana network and call it Bpf token, and people can use that. So not only can you create that token, but you could also swap it. For example, you could provide liquidity for it on Radium or through Serum. Any of the market makers provide liquidity, and you can basically swap that token with anything you provide liquidity with. The next piece is lending tokens. So you can, create lending protocols, again, using smart contracts, but that's something that's more complex, but I'm sure you could figure it out. Generating stake pools, maintaining on-chain name service, so Bonfida, they basically allow you to make a .sol account, so Bpf.sol, and that's the same concept as the ENS, the Ethereum name service, which is .eth. Associated token account program, which we haven't talked about, are custom programs. So writing programs are mostly developed in Rust again or C++, but they can be developed in any language that targets LLVM's Bpf backend. So if you want to get more familiar with this backend, you could search it up and figure it out and see what other languages sort of target this backend, so you can interact with it if you want to learn other languages, or you just know other languages and you want to check to see if the language can overlap in here. Recent initiatives by Neon Labs and Solang enable EVM compatibility and allow developers to write programs in Solidity. This is pretty interesting. This is a new thing that's just been pushed forward, and people are sort of working on it. The projects have some investment, and Solana is pushing this forward, it seems like, by putting it under Cookbook as well. So it seems like people will be able to write programs in Solidity and bring it on to Solana, which is going to be super interesting. Most Rust-based programs adhere to the following architecture: lib.rs, registering modules, entry point.rs, entry point to a program, instructions.rs, program API, deserializing or serializing instruction data, processor.rs, program logic, state.rs, program objects, deserializing state or serializing state, error.rs, program specific errors. Recently, Anchor has emerged as a popular framework for developing programs. Anchor is an opinionated framework akin to Ruby on Rails. This reduces boilerplate and streamlines the serialization or serialization process for Rust-based development. So if you're familiar with React for JavaScript, or you're familiar with Next.js for JavaScript, you know how frameworks sort of work. So a framework is just something that's built on top of a language to help you use it easier by abstracting certain concept or certain ways things are done, so you don't have to worry too much about it. It just handles it for you, or it makes it easier to do it, makes it like doable in fewer steps. So this is the same thing with Anchor. Anchor has just made a way for you to sort of plug in and play. All right, enough about Anchor. Just make sure you check it out if you're programming on Solana. Programs are usually developed and tested against localhost and DevNet environments before being deployed to testnet or mainnet. So testnet and mainnet are being run by Solana validators as well. They support these environments, mainnet beta. So mainnet beta is where Solana is actually running. So this is like the real deal. This is where everything is on. If you actually want to go live and put it like in front of people and have real life value when it comes to Solana like being traded on the market, this is mainnet. This is where everything should be. Testnet is the second layer. So you're almost there when it comes to, you know, putting things out there, but you just want to test in the environment for people to be using. DevNet is where you're developing stuff. So this is like purely, you know, as you know, you're starting to learn or you're just trying to put things out there for people to kind of interact with, but not necessarily like take it out there. Especially when it comes to Solana, because these accounts and programs are running with real Solana, which is worth real life money. So you don't want to put something on mainnet that's just going to be draining your account and not really doing anything, you know, useful in a sense. But, you know, I'm going to let you decide what's useful and what's not. I don't want to, you know, say that, but I'm just trying to let you know the different layers of what exists. Localhost is your typical default port, so it's just on your computer. No one else has access to it. You're just running it in your private computer. Anyway, once deployed to an environment, clients can interact with on-chain programs via RPC connections. RPC connections are relay protocols, so they essentially are the middleman that is whenever an application, you know, wants to deliver a transaction, the RPC node says, hey, I'm going to select this validator to, you know, deal with this, you know, transaction that's happening. So that's the architectural piece that's doing that. Deploying programs. So we're not going to talk too much about code in this. We're just talking about documentation. We just want to understand the architecture of Solana, what's going on, which components are doing what. But developers can deploy their programs via the command line interface. You just run this program in the name of the file path and whatever. When a program is deployed, it is compiled to an ELF shared object contained in Bpf bytecode and uploaded to the Solana cluster. Programs live in accounts, much like everything else in Solana. Again, you know, we have data accounts, we have program accounts, except these accounts are marked as executable. So the program accounts are marked as executable because they execute commands and assigned to the Bpf loader. The address of this account is referred to as the program ID, again, which is typically the public key of that account and is used to reference the program in all future transactions. So that's how you refer back to the account. You say, hey, give me this account with this public key. Solana supports multiple Bpf loaders, with the latest being the upgradable Bpf loader. The Bpf loader is responsible for administering the program's account and making it available to clients via the program ID. So it sets it up and it makes sure it's available to other people that want to use it or interact with it or reference to it using the public key. All programs have a single entry point where instruction processing takes place. So it has to go through here, and parameters always include program ID, the public key, accounts, array of accounts, and instruction data. So what are we going to do with this program? Once invoked, programs are executed by the Solana runtime. Anyway, this is just a quick rundown on the programs piece of the Solana architecture. So I hope you understood this and I hope it made sense. We're going to be discussing a lot more about this. You know, we're going to put all the pieces together over time. This is just the second piece, the second video of this series and journey. So we understand accounts, or at least just from an idea perspective, how they work. And then now we talked about programs and how those work. So next we are going to be talking about transactions, and I'll see you on the next video for that. Don't get too hasty. It's coming.
Don't speak to no one but the facts to the masses, pouring out the deuce in an all black outfit.